Hi everyone, I hope you are doing well. So we are going to have our class in week 9, right? In this week we are going to continue on chapter 5. So we are going to previous session we built model 5.1. Now we are going to work on model 5.2, and which is actually going to build on the model 5.1. So I want you guys to have hopefully the model 5.1 done and working, because we are going to build on that model and add more details to come up with the model 5.2. But before I continue, I'm not sure if in the last session I talked about these terms. We had the discussion, obviously. So if you remember last session, we in the call center that we modeled, if we had 26 lines, trunk lines, and if all of these lines were busy, then the customers or the calls that were coming to the system were going to be rejected right away. And then we defined a record module to record how many calls were rejected. And that's the scenario that the customers are forced to be rejected. So we call it customer rejection. But however, there are scenarios when, for example, a restaurant, when the customer comes to the system and they look at their number of people in the restaurant. So if there are so many people that are already waiting, they decide to just not wait and go back. So this is also similar to the rejection. So if I want to put the condition, for example, I put the condition that if more than or equal to, or if this number of people are waiting, then the customer is going to leave the restaurant. Okay, so that's exactly similar to the customer idea of the rejection. So if the specific number of customers are waiting, or if a specific number of calls are in the system, the customer is going to decide to just go and not wait for getting into the system. We call that customer balking. So customer balking just then is the same concept of as rejection when there are some conditions in the system. If the system is full or there is some condition. However, the only difference between rejection is that in the rejection, intuitively, like the rejection happens by the system. So the customers want to come in, but we close the door because it's lunchtime, right? So the rejection happens inside the system. But if it's a scenario when the rejection is decided by the customer, we call it customer balking. Like the restaurant, the customer goes in, since there are so many people, the customer decides to go and not to stay. So that's called customer balking. If the system forces the customers to go, that's called customer rejection. So I just wanted to make sure to mention that, because these are some of the terms that you may see or hear in simulation classes or projects that you may work on later on. So I wanted to make sure you guys are comfortable or know the customer balking and rejection. Okay. Now, okay, we are going to work on the new model. The new model, basically, as I said, is going to build on the previous model that we developed for the call center. And in this model, we are going to make a couple of changes. First, the arrival rate of customers changes over time. So in previous model, what we had was this constant arrival rate of customer, or constant inter-arrival time throughout the whole simulation time. However, for a lot of real-world systems, this is not the case. If you consider a bank, a call center, a restaurant, a supermarket, in all of these systems, the arrival of customers changes over time. So in the morning, we may get more calls or more customers, and then even slow down mid-morning, and then during the lunch, it may become more, and then slows down in the afternoon, and during the afternoon, like when people leave their work and things, they may again start calling, follow up for their phone or internet and things like that. So we may get more calls during those times. The same for a supermarket, the same for a barber shop, and even the same for a manufacturing process. We may receive different orders, but these orders may, the rate of these orders that we receive may be different in different hours of the week. They may be different in different days of the week, or different days of the month, or different months of the year. In all of these scenarios, the arrival rate is not fixed and is changing over time, and we want to see how we can capture that. The second thing that we are going to do is that we are going to work on the schedule of the staff. In previous model, we just said, oh, we have, for example, 3 people to answer technical call for product type 1. But then what we want to do right now is that assign these people to different type of calls. However, consider that these people may answer different type of calls. For example, 2 of the people that answered the technical calls for product 1 may also answer technical calls for product 2 as well. So then we want to see how we can capture this resource assignment to make sure that some of the resources that are used for some of the operations in the system, some of the processes, they actually can be used for some other processes as well. So we want to learn that part as well. The other one that we want to do is that 4% of the technical support calls that come to the system, they need further research and further investigation. And this investigation is done by an office outside the call center. So when the call tech support guy is done, if the call needs further investigation, they send the call to an office outside. So then the call is not going to use any resource from inside the system. No trunk line, no person, nothing. The call is going to be sent outside for an hour. It's being processed, and then the call is going to come back and get processed. And then if we are going to call back the person again and say, oh, we did the investigation and this is the result and we are done with the call. However, when the call comes back to the system from further investigation from outside, the call comes back, we get the results, we want to call the customer. We want to make sure the same agent that initially talked to the customer is the one that is going to call the customer back. Okay, so that's the little tricky part. So an agent processes the call initially. The call needs to go outside and gets further processing. When the results are back and we are going to call back the customer and tell them, oh, this is what we found and this is the result, we want to make sure that the same agent that talked to the customer the first time is the same person that is going to call back the customer and tell her or him about the results. And finally, we want to see if we have enough staff in different parts of the day. And to be able to make that decision, we want to see how many rejected calls we have in different hours of the day. And that is going to help us if in specific hours of the day we have too many rejections, then that helps us to see, okay, we may need to increase number of calls in a specific hour, or increase number of agents in a specific hour, or decrease number of agents in a specific hour, and so forth. So we want to be able to count number of rejections that we get in each hour of the simulation. In previous model, we counted number of rejections during the whole simulation time. But here we want to count number of rejections in each hour of the simulation. So these are the changes we want to make in this model. Is everyone clear about these changes? Okay. Let's go back to the model. So please open the model that we developed in previous week, in week 8. Save it as a new model in the folder for week 9. We are in week 9, right? So save it as a new model in the folder for week 9 and name it as model 5.2. Previous one was model 5.1. This is model 5.2, call center system. And then at the end, put dash with more details because we are going to add additional detail to this model. Okay. For the first part, let's look at the arrivals part. So if you remember previous part, we talked about terminating system and the fact that we want this model to do not send any customer to the system after the 10 hours of the working time are over. And And then we added these additional modules for calculating those dummy entities, so that we changed some of the variables related to the arrival process. If you remember, we changed some of the variables, calls per arrival and max calls at time 600 when the dummy entity came to the system, and that took care of the of making sure that no customer comes to the system after 600 hours. And then in the run setup, if you remember here, we put the other condition that stop the simulation after we pass the 600 hours of the simulation, and also make sure there is no customer in the system where our working process was 0. That's why we were calculating working process in the model ourselves. Although the simulation calculates working process for us after we finish everything and we run the simulation, but we wanted to calculate working process in the model explicitly because we wanted to use it as a terminating condition for the simulation. So this made sure that the condition of terminating systems are met. Can someone tell me what was the definition of terminating systems?
I believe a terminating system is one that stops after it either meets a terminating condition or a fixed amount of time, right?
Okay. Yeah. Can you give me some examples?
Sure. This example is that customers have left. All of the customers in the system have exited the system, and the model has run for at least 10 hours. You could also have a terminating condition after you've completed a set number of pieces.
Yeah, go ahead. Sorry.
So for a manufacturing process, you stop once you've built 100 widgets.
Mm-hmm. Yeah, that's true. So the terminating systems are the ones that have specific starting condition and a specific terminating condition. So a supermarket, a restaurant, a call center, a barber shop, a bank, these are all examples of terminating systems because, for example, in these systems, after a specific number of hours is done, we are not going to let any new customer to come to the system. However, we are going to continue the system till everyone who is already in the system get the service and leave, right? That happens in a supermarket too. After some specific time, let's say after midnight, they don't let anyone to come to the supermarket. However, they will continue another 40 minutes, half an hour, or as long as it takes till everyone who is in the supermarket gets the service, buys everything that they want, and then they leave the system, and then they shut down the system, okay? And then the starting condition for all these systems is the same. To every time that we run these systems, for example, for a supermarket or barbershop or call center, we want to start with 0 customer or 0 calls in the system, right? And so if we just run different replications of this call center, in each replication, we want to start with 0 call in the system. We want to stop after 10 hours is passed and there is no one in the system to require the service, then we stop the simulation, right? So that's the bold definition of terminating system. The starting condition and the stopping conditions are explicitly defined, and they are the same in every replication. And the opposite side, we had non-terminating system. And if you remember, a manufacturing process, for example, falls in the category of non-terminating systems sometimes because in a manufacturing process, and at the end of the day, we stop when the 5 p.m. comes, we stop. We don't care if we have finished every part in the manufacturing plant or not. We just stop and we come back tomorrow morning, and we start from where we left off the previous day. So the start condition of the second day is not necessarily the same start condition of the first day, won't be the same condition of the third day, fourth day, and so forth, right? So every day we start from where we left off the previous day, and then we want to stop in each day. We don't care if all the parts are out and things like that. We just stop when we reach 5 p.m. and that's it. So those are the situations where non-terminating system, and we'll learn how to capture those non-terminating conditions later. But for terminating systems, we want to make sure that we do not let any new entity to come to the system after a specific time. And also we want to make sure that the system is going to still continue working till every customer who is in the system is out. Okay, and then we added these additional entities, the modules, to capture that part. Right now, our arrival is not fixed anymore. Our arrival is going to change based on this table. So this is table 5.2 of your table. If you have your book or your PDF, you can use it. I put it here for those of you who may not have access to the book, so I wanted to make sure you guys see that. So the arrival rate of customers is not fixed anymore, and it changes in different hours of the day. From 8 to 8:30 is 20 calls per hour. From 8:30 to 9 is 35 calls per hour, and so forth, all the way to 6 p.m. So for each one of those, the number of calls that are received per hour in each one of these intervals changes, okay? And we want to see how we can capture this part, right? So this is very important, guys, because this is the situation for a lot of real world problems. So make sure you understand that part. So if you guys want, I would say take a print screen or screenshot of this page, because I'm going to go to Arena. You may not have access to this part. So, and we want to see how we can put these arrivals in the system, right? So to be able to do that, we are going to use the schedule module, yes, schedule function of Arena. So basically we define one schedule in which the arrival rates is the one that is being scheduled and is changing over time. We previously learned how to develop schedules when number of resources were changing over time. Now we are going to define a schedule for arrivals, and in that arrival rates are changing over time, okay? So let's go back to schedule. And here, define schedule. So this is going to be arrival schedule, okay? And this schedule is not for capacity anymore. Previous ones were for capacity. We defined the schedule of the resources, but this schedule is for arrival, okay, peak arrival. And then the units can be anything, right? You have the option to pick the units as hours, minutes, or anything. In one of the previous models, when we defined schedules for the capacity for the resources, we left it as hour, and here we said in the first hour we have only one resource. In the second 8 hour, in the first 8 hour we have one resource. In the second 8 hour we have no resource or 2 resources. So you can pick any one of them that works for you. However, if you look here, we see that our time frame is half an hour, half an hour, half an hour. So it just may be a bit easier in terms of Arena functionalities if we pick half hour as time unit, so that if I say 8, then it's not just 8 hours, is 8 half hours, and that's 4 hours. So, and then here we are going to add. So the first one, I have, for the first half hour, I have 20 rate for the rate. Okay. So value of 20 for this. So this is arrival rate, guys. So pay attention. If I was going to just put the arrival in the create module, I always need to put inter arrival time. But this is arrival rate, arrivals per hour. So this is the rate. So that's why I don't need to translate these rates to inter arrival time or anything. I just can, I can put just the arrivals, right? I just can put just the rate. So 20 for the first half an hour, and then 35, 45, 50, 70. 35 for the next half an hour, 45 for the next, 50 customers calls per hour for the next half an hour, 70 calls per hour for the next. And make sure, guys, these are in the order too, because if they are not in the order, then your whole schedule is messed up. So put them in the same order that you see here. And if by any chance you're here and you enter add and then suddenly something is added in the wrong place, you can always move them up and down by clicking on them, holding control, and then using above and button arrows. So yeah, above and button. So the arrows up and arrows down. Okay. So we can do that, but always if you click just on the last row, when you add something, it's going to be added to the last row. So the next one is 90, again for the next hour. Sorry, 75, 75, 90, 95, 105. The one to the last are 75, 75, 95, so it was 75, 75, 90, 95, so we did the second row as well, and then 110, 95, 105, 90.
Professor, how did you say we can move a time?
Just click on any one that you want, press Control, and then the arrow keys, when you go up and down and right, left, if I go up or down, then that moves up and down. Did you find it, the arrow keys?
Yeah, I'm trying to get it right now.
You have in my computer on the very right at the bottom on the keyboard, there are page up, page down, right, left.
I just don't know. Is it different for a Mac? Because I'm trying to do it and it's, I don't know if like the controls are different.
I haven't tried on Mac, but it should be the same. Do you hold Control, right? And then the arrow keys. It should be the same. So let's see here.
It's Control Option and then arrow key for Mac.
Yeah. So it's for Windows is also the same. Control for Windows is Control and arrow keys. Does that work for the Mac too? That's my question.
No, it's Control Option and then
Oh,
arrow
I see. Oh, Control, Option, and then arrow key. Okay, good to know. Thank you. 105, 95, 105, 90. So it's 20, 35, 45, 50, 70. 20, 35, 45, 50, 70. 77, 75, 75, 90, 95, 105. 110, 95, 105, 90, 85. 90, 70, 65, 45, 30. Okay, everyone is done with defining the schedule for the arrivals. The time unit is half hours. I think for one of the homework I had recommended that you guys pick quarter hours because the break time were only 15 minutes, so that would be easier to enter the break time and working time if you use the unit of time in this schedule as quarter hours. So these units of time in defining the schedule gives you flexibility if the break time is only 15 minutes, half an hour, and so forth. So this you have flexibility with these units of time. So here we leave it in half an hour because everything we have here in our schedule, in our arrival table is based on half an hour. So it's actually helpful for us. Okay, press OK. Make sure to save. So now what we want to do is that we want to go to the arrival, to the create module. And here for the create module, if you remember, we said previously the inter-arrival time was a fixed it was a fixed value for the whole simulation time. It was exponential, but the inter-arrival time was fixed for the whole simulation time. So if the inter-arrival time is going to change, and we defined already the one schedule for that, we are going to, instead of type instead of random or exponential or constant, we are going to pick schedule. And then it asks, okay, what is the schedule name? Arrival schedule. Okay. We can leave calls per arrival and max call as they are here because the initial value of calls per arrival is 1 and max call is like 99.999. But or we can just change them to 1 because every time an arrival is made in the system, the calls are coming to the system one by one. And also here we can put infinity. However, the calls are not going to come to the system for as long as we run the simulation, because in the schedule that we defined for the arrival, we did the schedule for the 10 hours, so nothing is going to be generated after that. If the arrival is going to be based on that schedule, no arrival is going to be generated after that. And everyone is good? So make sure to, for your arrival, choose the schedule and pick the schedule that we just defined where the arrival rate is going to change, and the simulation automatically calculates the inter-arrival time because simulation knows what we define in the schedule is arrival rate. So the simulation calculates the inter-arrival time behind the scene and use it. And since we don't need these parts anymore, since the simulation automatically stop after, since the simulation will not generate any arrival after those 10 hours that we defined in the schedule is done, we are good to delete this part because we don't need to do anything to stop the simulation from generating arrivals. The schedule is for 10 hours and will automatically take care of that. So we can delete the top part. Make sure to save, guys, as we go forward. Okay. The next thing, okay. Next, here in the system, remember at some point at the start, we define an assign module. Do you remember what was the point of, oops. Remember in this assign module, after we checked if we have a trunk line or an empty trunk line and the call came to this, we seized the trunk line and the call came to the system, then we started counting work in process, which is number of calls in the system. Do you remember why we did that? Where did I use this work in process variable that I defined in the model?
In the terminating condition.
In the terminating condition, right? So now, okay, keep that in mind. And everything was good, no worries. So keep that in mind. And remember here, I also, when I wanted to check if there are enough trunk lines available so that the call comes to the system, I also put some condition here. And in this condition, I said NR trunk line is less than MR trunk line. Can you tell me what was this one? What was NR trunk line? What does it calculate?
Number busy versus number scheduled.
Yeah, so NR trunk line is the number of trunk lines that is busy, right? So can you tell me then, what is the relation between this? So whatever NR trunk lines return to me, anytime I call it in the simulation, whatever NR trunk line returns to me is number of trunk lines that are busy, right? How that is related to the working process, which is number of customers in the system.
It's exactly the same.
They are exactly the same because remember, every time a customer comes to the system, we seize a line right away. So if I can count number of lines that are busy at any point of time in the simulation, that's basically my working process. That's number of customers that are in the system, because as long as a customer is in the system, is either waiting to get answered by the agent or is being answered by an agent and things, a line is seized by that customer. Okay, so then the number of lines that are busy, the number of lines that are seized by these calls that are coming to the system is basically my working process. Those are the number of calls in the system, right? So here, just for the sake of learning, otherwise you can just keep everything the same, I'm going to delete this assign module that we put to calculate working process. So I'm just going to delete it. And I'm going to just relate these two modules, connect them again. I deleted the assign module here. And then in my run, in the terminating condition, I'm going to put, since I don't like to write as much, I'm just going to copy it from this decision module that we have. But in the run, in the setup, instead of total working process equals to 0, which I'm not going to calculate anymore because I deleted the assign module that calculated this working process. Instead of total working process, what I'm going to put? NR trunk line. That function is going to calculate number of trunk lines that are busy in the system, and that's exactly my working process or number of calls that are in the system. So if I pass the 10 hours and of the simulation, no customer will be generated and everything, and then if the number of calls, number of lines that are busy in the system is 0, my working process is 0, then I stop the simulation. Okay, so this is just so you know, you can put some of those conditions and everything here. We don't have to necessarily define working process. And again, this is for this system because the setup of the system is such that the number of calls, the number of lines that are busy shows the number of working process that we have. But this is not the case in a lot of other systems. So if that's the case for those scenarios, you have to calculate your working process. So if everyone is okay, press OK and save. Next. Okay. Now let's get to the record module here. Remember, if we click on the record module, what happened is that we had assigned a counter here, and this counter just increased by 1 every time that new call was rejected. Every time a call was rejected, that counter was increased by 1. So we defined that as a counter. Now what we want to do is that we want to count number of calls that were rejected in every hour of the simulation. For every hour of this 10 hour, I want to have a counter that tells me how many calls were rejected, right? So for that, I'm going to define something that we call as a set. We haven't defined a set before. What is a set? A set is a collection of similar items. So a set can be a collection of counters. We can define a collection of counters, similar objects in a set. We can put a collection of entities in a set. We can put a collection of attributes or variables in a set. We can put a collection of entity pictures in a set and so forth. So there are various things that we can put in a group and together, and we call that a set. So a set is a collection of similar items. And when we click here, we can create a set. So here, what I want to do is that I want to define a set of counters. Okay. And in this set of counters, I'm going to manually add these counters. So in the first one, I'm going to say that this is for period 1 counter. Okay, so this counter, the first counter that I'm defining in this set, is going to count number of calls that are rejected in period 1. Okay, so, and then later you will learn how we can use that in the record module, how we can use this index so that we count number of calls that are rejected in each hour and record it in each one of these counters that I'm going to define. So basically, when we put these counters in a set of counters, it's more like an array of objects, array of these counters. So then I can always refer to the set and refer to the first element of this array, and that's the number of calls that were rejected in period 1. Okay, so here, so before we forget, let's go to the name of this set and let's call it rejected calls set. Okay, rejected calls set, and this set is a collection of similar items. These items are counters. So here I'm going to add 10 counters to this set, one for each period, and later when I want to refer to this period 1, period 2 counters, I'm going to use this name and then an index. So I know index 1 refers to period 1, index 2 refers to period 2, and so forth. So whatever order I put here, that would be corresponding to index, the first index of this set, the second index of this set, and so forth. So here I'm going to add another counter. That's going to be period 2. Again, similar to the schedule, make sure you put them in the order, period 1, 2, 3, 4. If you mix the orders for any reason, choose control arrow up and down to put them in the right order. Okay. So here we define a set. I'm going to call it rejected call set. The elements of this set, they can be different things. We can put a bunch of resources in a set. We can put a bunch of counters, a bunch of tallies, entity types, entity pictures, and so forth. So these are the things, as I said, similar entities. These are some of the things we can put in a set. We also have another module in the advanced processes template. It's called advanced set. So that's for other type of sets. We will work with that later. But for this one, we just want to put counters, and I put manually, I create 10 counters and I put it in this set. Okay, press OK. Press enter. And now in this record module, so remember, so click on the record module, click on the first row that we had and press edit, because we want to edit that, right? Previously, we just had one counter for all the simulation time, but now we want to use the set again. The type is count. Here you see the option record into set. We didn't use that before. Check that one. Record into set, and then it says, what is the set name? Rejected call set is the set name. And then what is the index of the set? So when the calls, every time a calls passes this record module, the calls is rejected, we are going to increase this counter by 1, okay? But where do you want to save it? Remember, this rejected call set has 10 indices for period 1, 2, 3, 4, 5, all the way to 10. Which index we want to use? So to be able to define the right index, I'm going to use, 1 second. AIENT, A integer. Okay, so first let's write it and then I explain to you what it does. Parentheses, another parenthesis, T now divided by 60 plus 1 and close parenthesis. Okay. So I'm just going to copy this.
Professor, since we're using half hour, should it be 30?
No, that's only for the arrival. That's only.
Sorry, that makes sense.
Don't worry. Yeah, any question is good. That's only for the rows, but here the simulation time, also because the simulation time is in minute. Do you know how I can make sure the time, T now returns the simulation time, right? You remember that from previous exam. T now returns the simulation time and it returns it in minute. Why? Because in the run setup, the base time unit is minutes. So if the base time unit is minute, the T now function always returns the simulation times in minute. So what I'm doing here is that I get the simulation time, I divide it by 60. So let's say I'm in the first hour. I get the simulation time, let's say I'm in minute 30. I divide it by 60, the results is 0.5, right? So the simulation time is 30 minutes, I divide it by 60, the result is 0.5. And then I add 1 to it, the result is 1.5. And then this whole thing, which is 1.5, is given to the int function. And what does this function do? It truncates the number, it removes the real part and just gives me so it doesn't round to the up or to the lower integer. It just truncates the real part, the 0.5 part, and just returns the integer part. So if I do that, for example, for any minute between 0 to 60, it will return always 1 for me. And that's actually the index that I want to do for the first hour of the simulation. I want the index that is going to be returned from this function. This function basically is going to return 1 for the first hour of simulation. No matter which minute I am, for the first hour of the simulation, this function is going to return 1. So that would be the index of the element that I'm going to pick from this set. And inside that, and that element, I'm going to just increase it by 1 every time a call is rejected, right? So every time a call is rejected for the first hour, I'm going to pick the first element of this set, which are the rejected calls for period 1, and I'm just going to increase it by 1. And at the end of the first hour, the value of the first element of this set is going to give me the number of calls that were rejected in the first hour. When I go to the second hour, then the simulation time, remember, just continues. Now the simulation time is 65, 70, 80, 90, 10, 100, and so forth. So let's say simulation time is 100. So 100 divided by 60 is obviously 1 point something, right? If I divide 100 by 60, that's 1 point something, and then plus 1, that would return 2 point, that would return 2 point something. And then again, when I give 2 point something to this a integer function, it will always return just the 2 part. 2 point something, it removes the real part, the point something part, and it always just return 2 for as long as I'm in the second hour of the simulation. And in that scenario, this counter always is going to increase the value of the second element, the second index of this set by 1. Okay, and then when I go to the third hour, it's going to pick the third element of this set, and it's going to start increasing that start from 0 and increase that 1 by 1 till we go to the fourth hour, fifth hour, and so forth. And that's how we can calculate number of rejected calls, not just during the simulation time, but in every hour of the simulation, so that later at the end, we can look at the number of rejected calls in each hour. If there's a specific hours when the number of rejected calls is significantly high, we can think about hiring more people or doing something about that. Is it clear, guys? Okay. Make sure press OK, and make sure to save as we go forward.
Also, Professor, can you go back to the setup again? I think mine differs from your model as I have 10 rows of counters.
I also have 10, no? Oh, I don't have period 1.
Professor, and it looks like you're missing period 6 as well.
Okay, it's quite possible. Period 1. Oh no, I do have. What happened? Period 1. Period 1, 2, 3, 4, 5. Okay, I do not have period 6. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. All good? Thank you guys for pointing that out. Okay. Okay, so let's go forward then. If we go back to the PowerPoint for the things we wanted to do, we took care of that part. Arrival rate changes over time. We did take care of that part. For the scheduling of the staff, we haven't done anything yet. For the 4% thing, we haven't done anything yet, but for the number of rejected per hours, we finished. So we finished the first one and the last one. The second and the third are left. Okay. Okay, now let's go forward. Everything else will be okay. The thing with the sales people, with the sales calls is the same. The thing with the order status call is the same. With the technical calls, those are the ones that have the 4% going back for additional further investigation. So I just pick the very last items and I just bring them down just to open a space here because I want to add the other parts. So for this one, okay, so let's delete this because when we are done with processing the calls, they are not just going to go through the rest of the process and leave the system. 4% of them may need to go back to the outside for further investigations and so forth. So we want to be able to capture that.
Should we also delete the final assign module? Now we're not using the total work in progress.
I will do that when we get to that point. I'll mention that. Okay. Also move these processes to the right. I want to put an assign module here. That's why I want to create space. So here I'm going to put assign modules. And in this assign module, I'm going to do a couple of things. So for the products that are related, so these are the technical calls, right? If you remember when the technical calls come, we just assigned a different entity type, just these are the technical calls, right? And we assign them a picture, the different picture, so that when the simulation runs in the animation, we just see a different picture for the technical calls. And then they went through the delay, and then we wanted to decide what type of product these questions are related to. So then we put the side module. Then we decided with the chance of, I think, 35% and 24% and the rest, that if these technical support questions are related to product 1 or product 2 or product 3. Now, what I want to do with this assign module, I also want to define a different entity type to each product type question. Just because at the end, I want the simulation to give me statistics for each one of these product types. Remember, when we define different entity types for order status or the sales calls or the technical support, at the very end, when we ran the report, when we ran the simulation and we got the report, you did not have just one value for the entity call that we entered initially. Now I had the results for not only the entity call, but also the tech support call and the sales call and the order status call. Just because I assigned them a different entity type, simulation reported the results for each one of them separately. I want to do the same. I want to assign different entity types to each product type call, and so that I can get statistics for each one as well. I want to assign a different picture so that during the simulation I can see them as different picture. And I also want to assign one attribute that is going to takes value of 1, 2, 3 for different product type. And later I will show you, I will tell you how I'm going to use this attribute. So later we will see the use of this attribute that we are going to define. So here in this assign module, I want to assign entity and pick to product 1 to take call product 1. Okay, so let's do that. So add entity type, what I want to call the entity name, take call product 1. I'm going to add an entity picture to those entities that come through this path, means they are product 1 calls, and entity picture. So I'm going to pick yellow page. Previously we picked yellow ball, blue ball, and things like that for the different type of calls. Now for this technical calls, which are related to product 1, I'm going to pick yellow page. Pick any icon that you like, it doesn't matter. And lastly, I'm going to define an attribute. And I'm going to define this attribute as take call type. Okay. So this attribute is going to get value of 1 if the take call is related to product 1. It's going to take value of 2 if the take call is related to product 2, and value of 3 if the take call is related to product 3. So the value of this attribute for those entities that go through this route is 1. It's okay. And the next assign. So assign entity type and pick to take call product 2. Again, I'm going to define entity type. We are going to call it take call product 2. I'm going to assign entity picture. And for this one, I'm going to use red page. And the last, I'm going to, for the attribute. So remember, now for the take call type attribute that I defined in previous module, I'm just going to give the value of 2 to those entities that go through this path. those 24% that go through dispatch, right? So just make sure. I saw in some of the homework assignments that make sure you're not going to define a new attribute. So you already defined the attribute. The attribute is take call type. That's already a tag on each one of the entities, even the sales calls, even the order status call, although they have nothing to do with the tech call type and so forth. However, for those entities, the value of this tag is 0. Don't worry about it at all. But for tech calls, the ones that come through this path, this tag is going to get value of 2. That means they are related to product type 2. Okay, so make sure you're not going to define a new attribute. It's the same attribute that you define. It's just that you want to give value of 2 to this tag for those entities that go through this path. The entities that went through the first path got value of 1 in the tag. And press OK. And do the same for product 3. They call product 3, that's my entity type. Entity picture. I'm going to choose green page for this one. And lastly, the attribute. And again, the attribute is already there. You already have defined the tag. All you need to do is that for those entities that go through the third route, or product 3, you want to make sure this attribute gets value of 3. And press OK. And make sure to relate them to the right branch. So the 35% go to this, the 24% go to this, and the else part goes to this. And relate the sign to the process module. Okay. Everyone is good? Everyone is with me? Okay. So now, one more thing we did here is that we said we also assign different staffs and different schedules to the people who are taking care of the calls. And so let's see how we can take care of item number 2 in this PowerPoint. So here is basically what happens, right? So here we said, oh, there is technical, take 1 people, and I think we had 3 of them, and take 2 people, and we had 4 of them, take 3 people, I think we have 4 of them as well. Let's see. Yeah. 2 take 1, 3 take 2, 3 take 3, 4 sales people, and they were the ones who were doing things. And then the values of the availability of these resources did not change at all during the simulation time. So we had fixed number of resources. However, not only the availability of these resources are going to change, however, one other thing that we have, which we want to capture, is that some of the staff that are working on product 1 are working on product 2 as well. Some of them, not all of them. And they are working on product 3 as well. So those staff should be available to provide service to each one of these calls if they are idle, okay? The way we have done so far, these 2 entities are only for product 1 calls. These 3 entities are only for product 2 calls and so forth. So we want to see how we can make sure some of these resources can be used by any of these call types if they are available. Not only the schedule of resources, which you already know how to define, but also the availability of them for different type of the calls. So what I want you guys to do is to open your resources, oh, okay. So let me see if I have it here. Okay, here's what happens. Here, basically, these are our staff. These are the names: Charity, Noah, Molly, Anna, and so forth. Here we know who is working on which product. So Charity, Noah, Molly, Anna, and Sammy, they all are working on product 1. Molly, Anna, Sammy, yeah, Molly, Anna, Sammy, and Mia, Jan, and Chrissy are working on product 3. Molly, Anna, and Sammy are working on product 1 and 3. And then for product 2, we have Emma, Aiden, Kearney, which are working on product 2. However, we also have Molly, Anna, and Sammy that are working on product 2 as well. So this is what I mean by having some resources that they can work on different products. So if a call comes that is from product 3 and Anna is available, no problem. Anna is going to answer that call. But if a call comes that is for product 3 and everyone here is full and Noah is idle, no, Noah is not going to answer that call. Noah is only for product 1. Okay, so we want to see how we can capture that one. And the other thing is that for each one of these resources, this is the schedule. So these are each half an hour, first of all. And again, this could be hour, this could be quarter hour. It has nothing to do with our arrival being defined in every half an hour. It's just randomly that our working time is also an hour. And it's usually the same because the person may work half hour, like 3 hours and a half. So if that's the case, then it's easier to define the time you need for this schedule as half an hour as opposed to 1 hour or quarter and so forth. So what happened? What the first row means? The first row means Charity is working first 1, 2, 3, 4, 5, 6, 7 for the first 7 half an hour, which is how long? It's 3 hours and a half, right? In 3 hours and a half, there are 7 half an hours, and then it's going to take a half an hour lunch break, and it's going to work for another 9 half an hour. That's 4 hours and a half, and then for the first 2.5 hours, this person is not working. So just note that here we have 22 half an hour. And that's basically, so if you divide 22 by 2, that's 11. That's 11 hours, right? So although the whole arrival and everything is defined for 10 hours, and the simulation is going to stop letting people to come to the system after 10 hours, some of these people are still available to work in the next hour because we may need to be there to work on the calls that are already in the system, right? So that's why the schedule of these people doesn't finish at 20, at half an hour 20, which is equivalent to 10 hours. It finishes at 22, after 22 half an hour, which is equivalent to 11 hours of working. So that if some staff need to work on the calls that are already in the system, then we have some people to do that. So that's why the schedule is 22 hours. So basically that's how I want you guys to read each one of the rows. So what I want us to do is to first, let's go to resources and define one resource for each one of these people. So in the resource, keep the trunk line, keep the salesperson, but for the take 1, take 2, take 3 that we define, either delete them or just change their name and put these 2, 4, 6, 8, 10. We have 11 of them here. So put these people as separate resources here. I will tell you later why we define each one of them separately. Okay, so in your resources, keep the trunk line, keep the salesperson, remove take 1, take 2, take 3, and add these 11 resources. And if you have the book, please open it. This is table 5.3 in page 238. If you don't have the book, take a picture from this page take a screenshot. I'm going to go back to the model. Okay. Okay. So I kept the trunk line. I still have 26 of them. I kept the sales person. Previously we had 6. Right now we have changed it to 6. Previously we had 4, changed it to 6. We have 6 sales person. So I kept the sales, I kept the trunk line, and then I added these 11 resources. Charity, Noah, Molly, Anna, and for everything else, the capacity is 1. So obviously, these resources have a schedule. That's the schedule that we saw here, right? So we need to, it's not that, oh, you just have one of them and it's fixed capacity for the whole simulation time. These additional resources that we add, they are working based on this schedule. So what do I need to do next is to go to the schedule module and define one schedule for each one of them. Okay, guys. So we defined the resources. Now let's go back to the schedule and define the schedule for each one of those people. So we already have 1 for the arrival. So we need to define 11 schedules based on what we see in that table that I showed you, in this table, right? So here, for example, for the first schedule, which is for, charity. So I'm going to call it charity schedule. It's related to capacity. The time units are going to be half hours because what I have here is in half hours, so it's easier to do that. So the first one, this the value of the capacity is going to be 1, 4, 7 of those time units, which are half an hour, right? And then value of capacity is going to be 0 for one of those half an hours, because that's the break time. That's equal to half an hour 8, if you see in the first row. then it's going to be again 1 for 9 of those time units, which are half an hour. So that's 4 hours and a half. And then again, it's going to be 0 for 5 of the last time units, which is the last 2 hours and a half, right? So this is going to be the schedule of the first resource. So make sure the time unit is half an hour, and then make sure to put the number of hours, number of time units, and in fact, number of half an hours for which we have this resource available as 1, or 0, that means break time, or the resource is not available anymore. So we want to do that for all of the resources.
Excuse me, Professor.
Yes.
Can I have that schedule, like the table again, please?
Sure. Give me 1 second. Let me see what. Module name, sorry. Here.
Thank you.
Okay, guys.
Professor, your Anna's schedule is in hours?
Is okay. I'm still recording, right? Okay. So everyone defined the schedules, right? For the we already had arrival schedule, but we added 11 more schedules for the 11 resources that we add. Remember here we had 11, we added 11 resources, so we added those schedules. And then for each one of them, let's go here and allocate the schedule. So it's not going to fix capacity, it's going to be based on schedule. And what is the schedule name? Charity schedule. For Noah, based on schedule. So leave the salesperson for now. We get back to it in a bit. So for the rest of the resources. Okay. So we came to so we defined the schedules. We defined the resources first, and then we defined the schedule for each one of the resources. Now we are back to the resources, and instead of fixed capacity, we say these resources are available based on this schedule that we have defined, and we define the schedule name. And for the rules, automatically is defined as wait, but I would say consider it as ignore. The reason is that, first of all, if an agent is talking to someone and then the break time appears, the agent is not going to stop talking to the person, right? So the agent is going to continue. However, we don't want to expand the break time of the person. I mean, if the person is going to spend 5 minutes of the break time to talk to a person, we are not going to just let it to continue take half an hour. So the break time is going to be 25 minutes. And the reason is that, I mean, it can be dealt with, but it just gets a little complex because once we push these 5 minutes, 10 minutes of break time, and then the whole schedule time, and then another break time, and then end of the day, and all of those are pushed back. So it just changes the whole schedule and everything. So because we don't want to do that, for the schedule rule, we are going to use ignore for all of them. For all these new ones. For the salesperson and for the trunk line, leave it as wait. But for the rest, for those 11 ones that we added, just leave the scheduled rule as ignore, which means if in the middle of a call, break time starts, they're just going to finish the call, then they go to the break, but they will come back at the time that they have to come back. So they are not just going to wait a little longer for the break just because they were talking to someone on the phone. Okay, so Make sure all of them are ignored instead of except trunk line and salesperson. And also, I want you guys to define one more schedule. If we go back to this rate, this table when I showed you rate, you see here at the bottom it says we have 6 salespeople. That's why here for the number of salespeople we've changed the capacity to 6. However, the salespeople also are coming based on a schedule, and this is how this schedule is given to us. The number of people at time period in minutes. So for the first 60 minutes, 1%. For the next 60 minutes, 3 people. For the next hour and a half, 90 minutes, 4 people. 60 minutes, next 65, next 66, next 95, blah, 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 till all this 11 hour of working time for the personnel is open. And again, just remember, the arrivals are in the 10 hours of the work time. But however, the schedule of the staff is for 11 hours because we know they may need to work beyond that 10 hours. So the schedule of the staff, all of them, the ones we just defined right now, and also these ones for these salespeople are in 11 hours. So let's go to the schedule. We already have the resource of the sales people, right? But here we just said it's fixed capacity 6. However, it's not the case. It's based on the schedule, and this is how you define the schedule. So if you have a screenshot of this, just go back to the schedule and define one more schedule for the resources, for the salespeople, and we assign that as well, and then we're good to go to the next one. So let's go to the schedule.
Hi, Professor.
Yes.
For the schedule with the add-on schedule, there should be 4 rows in the duration.
Can you repeat one more time?
For the schedule, for the add-on schedule, you should have 4 rows in the duration. You just have 3.
Okay, it's possible. So what is the situation? Aidan, 5 units, and then for the first, next 4 is 1. Oh, I missed the 1. Let's see. Thank you for catching that. So the value of 0 for 1, and it should go up. Yeah. Thank you. Oh, the rest are good, right? Yes. Thank you, guys. Make sure to save. Okay, let's go to the schedule and let's define in the schedule for the salespeople. Sales schedule again. Pick the half hours, and then here we want 1 for the first 2 unit of time, 3 for the next 2 unit of time. Okay. You guys have the same value. 1, 2, 3, 2, 4, 3, 5, 2, 6, 2, 5, 3, 6, 3, 5, 1, 6, 2, 2, 2. 3, 2, 2, 2. Okay. So we have the sales schedule defined as well. Let's go to the resources. And for the sales, instead of fixed capacity, let's pick based on the schedule. And here, let's pick the sales schedule. For the sales schedule, leave it as wait. Okay. Save. Make sure to save, guys, after all this work. Okay. Now we define the resources. Everyone is good? Everyone is with me? Can you please confirm everyone is okay?
Professor, one question.
Go ahead.
For the salesperson, which schedule rule should we assign for them?
The schedule that we just defined. We just
schedule rule.
Use the wait.
Okay.
For the trunk line and for the salespeople, use wait. For the rest of them, use ignore. Okay. So now we want to go to, remember this section when I told you these people can assign different type of calls. So some of them can handle different type of calls. Some of them can handle only one specific type of call. So we want to do that. So the way to do that in Arena is again by the help of sets. So what I'm going to do is to define a set of all the resources that can handle product one. And then in the processes, when we seize a resource, I'm going to seize a resource of this set. And then I'm going to create another set, which includes all the resources. Remember, the set is a collection of similar objects. So these are all resources, so it's perfectly fine. So, and then I define another set, which is going to be the collection of all resources that I can handle product two. It's absolutely okay if Anna and Sami are in set one are in set one that we define, and they also belong to set two as well. It's absolutely okay. An object can belong to multiple sets if it's needed. And then I'm going to define a third set in which I'm going to put all the resources that can handle product three. And as you can see, Molly, Anna, and Sami are going to be not only in set one for product one, but also in set three for the product three. Okay, so let's do that and then see how we can use this set, which are just basically a group of resources in the process module, to say that these are the people that are going to do this job are basically coming from these sets. Okay, so let's go to the sets. Let's click. So here is going to be product type 1 set. And this set, the previous set that we defined, remember, rejected calls, was a collection of counters. But this set is a collection of resources, right? So this set is a collection of resources. So pick resources, and I'm going to assign the elements of this resource, the objects that belong to this set manually. So the first one is a single element, is for the first set, Charity, Noah, Molly, Anna, and Sam. And I want you guys to define them in the same and I want you guys to put them in this order that we see here. So put Charity and Noah first, then Molly, then Anna, and then Sami. I will tell you later why, but please keep that order, it's important. Noah, Molly. And for product type 2, guys, for the set of product 2, please put Tierney, Aiden, Emma first, and then put Anna and Sami last. So put the ones for every set, put the ones that are allocated only for that product first, and then put the ones that can work on other products as well. So for product 2, put Tierney, Aiden, Emma first. For product 3, put Mia, Jan, and Christy first, because they are only for product 3. Then add Molly and Sam. Okay, so now I have 3 sets for the resources that are responsible for product 1, 2, 3. Just to make sure we are all on the, so for product 1 and 2, I have 5 rows. For the last product, I have 6 rows. For product 1, the order of the resources that I have is Charity, Noah, Molly, Anna, Sami. If you have different orders, guys, you are not going to get error. However, the reason that we put the order in this way is that if you look at the schedule table, Charity and Noah are only responsible for product 1, and the Molly, Anna, and Sami are for product 2 and 3 as well. So when we put them in this order, later when we assign them to the product 1 questions, we can tell them that use this order. In that scenario, always the simulation is going to pick the Charity and Noah first if they are available, and then use Molly, Anna, and Sami. And what is the advantage of that? The advantage is that Molly and Anna and Sammy can also work on other product as well. So if the simulation first uses Charity and Noah, then these other resources will be available to work on other products in case the demand for or the calls for other products are more. That's why I told you keep them in this order. But again, if you have different orders, you're not going to get an error. But in terms of the allocation of resources in the simulation, it's better to do that so that the other resources that are working on other products as well are left idle if possible, so that they work on other products if another order comes up. So for the product 1, I have Charity, Noah, Molly, and Sammy. For product 2, I have Tierney, Aiden, Emma, Anna, Sammy. And then for product 3, I have Mia, Jan, Christy, Molly, Anna, Sammy. Do you guys have the same order? Make sure to save, guys, as we proceed. So now what I need to do is to go back to the processes. Here is where I initially was using Tech 1 people to seize delay resource to answer the calls related to product 1. So now press edit, and in the resources, so instead of in the type, pick set. Okay, so just to make sure we're all on the same page. When we are done with defining the additional resources and with defining the additional sets for product type 1, type 2, type 3 calls, which are the resources that can process these calls, go to the processes where we answer technical call type 1. In the resource part, press edit. Here, when it says Tech 1 is used only 1%, instead of resource, pick set, and the name of the set is product type 1 set. We're going to use only one of the people or one of the resources in this set. Now, it says, what is the selection rule? Obviously, in this set, there are a lot of resources, right? How are you going to assign them to this task? What is the base of this selection? So it can be either cyclical. So these are the ones when they take basically turn. For the first call goes to the first one, the second call goes to the second one, the third call goes to the third one, and so forth. So they take turn. Random is just randomly the calls are assigned to these people in this set. Preferred order is the one that I mentioned. Preferred order is I prefer to assign the calls in the order that I have put these resources in the set. So that's why I said put the resources that are only for call 1 and 2 and 3 at the top, and the resources that can answer multiple calls at the bottom, so that when the call comes, it goes to the ones on the top which are related only for that product. And then we have the smallest number busy, largest remaining capacity, and so forth. So we'll have some of these in the other examples as well. And also we have here a specific member. If you pick a specific member, then that means I know exactly which person in the set has to finish this job, and then I also have to give the index of that paper. If this person is the first person, the second person, and so forth, okay? So here I would say my rule is preferred order. Based on the order I have put them in the set, pick them based on that order and assign the job. And here, remember one thing that we wanted to do was that after we assigned the jobs, some of the technical orders, 4% of them need additional research. And we basically say goodbye to them. We send them outside for additional research. An hour later, they come back with the results. We have to call them back with the same, however, the same person who talked to them initially should be the person that is going to call them back. Okay, so now when this person from the set is picked to process this call, I somehow have to get a hold of the index of that person, because in that set of the product type 1 set, remember we have 5 people. I put them in the order. The first person has index 1, the second person has index 2, index 3, and so forth. So if the second person, for example, is the one that has ordered, that has answered this call, I have to somehow get a hold of the index of the person. I have to know, oh, that was the second person. So that later when if the call went out, later when it came back, I can go pick the second person who processed this call initially and assign it to that person again. So what I'm going to do here is I'm going to define an attribute here. And so this would be a tag for all these entities. And in this tag, I'm going to basically to save the index of this person that has been picked to process this call. So I'm going to call this tag as, you can call it anything, but if we want to make sure we pick the right name. Take agent index. So take agent index. Okay. So obviously I had not defined this attribute in the past. That's fine. I'm going to define it here and it will be automatically defined in the simulation. So this attribute, take agent index, is the attribute or the tag that each one of these calls is going to have and keeps the index of the person of the tech resource that has processed this call. Okay, so that's going to stay there. Press OK. And the processing time and everything stays the same. Press OK. For the next, for the second type of the call, we are going to do the same as well. I'm going to press edit for the resources. Instead of resource, I'm going to pick sets. The name of this set is product type 2 set. I'm going to use one of the resources in this set. The selection rule is based on the preferred order, based on the order I define in the set. And I'm going to save the index of that resource in the set, in the take agent index attribute that I defined just now. Don't define a new attribute. Don't type it again. Pick it from this. So here, every attribute we have defined is already here. So take agent index is the attribute that I defined, which keeps the index of this agent in the set. Press OK. Press OK. And lastly, for the tech call type 1 processing, I again press edit. I pick sets, define the name of the set. So that's product type 3 set. I need one of the people in this set, one of the resources. Selection rule is preferred order. Based on the order I put them in the set. And I want the index of this person to be saved in the tech index, tech agent index. So you see it says save attribute. So these are the features that automatically are in the core model. So when you put the name of the attribute here, this attribute is going to save the index of that resource that has been assigned to this specific entity. So that later when the entity comes back to the system, we can look at this attribute and say, oh, you talk to the second resource of this set. You talk to the last, fifth resource of this set. And then we can pick the same person to answer the call again. So press OK. Make sure to save. Okay. Now, so we said after we are done with the technical calls, 4% of them need to talk to outside resources. So we put the decide module. We say talk. Okay, so let's say outside research. We need outside research if the answer is yes. So first of all, okay, it's two-way by chance. And if the answer is yes, we need outside research. These are the 4% that are going to be sent outside and then come back later and so forth. So I write it in a way that the 4% is the ones that need additional work. Okay. The other 96%, which is else, are the ones that don't need anything. They are good to go. So make sure to connect these process modules to the decision modules. Okay. For these 4% that need some additional work, so they are going to go outside. So what is the first thing that happens? I'm talking to the person and I say, oh, actually, I cannot find the answer to your question. Let me talk to our, I don't know, partner, wherever in this company, in whatever company, I will call you back in about an hour. So what happens in the system? What is the first resource that is going to be released? Because we don't need that anymore.
Trunk line.
The trunk line. So I'm going to advanced process panel to pick a release module, bring it here. Let me put this down. And this is going to be release trunk line. That's not the same. So we have the same name. Just make sure. Okay, so to say, because we have this name for another release trunk line that we have, so make sure to give it a different name. Release trunk line for offline research. Okay. And I'm going to release trunk line. Okay, so release trunk line, make sure to pick the trunk line as the resource that is going to be released. Then it takes about 60 minutes exponentially distributed to process this call by another department outside this call center. So all I need to do for that one is what? Capture that in the simulation. All I need to do is, so the call is going to go to a different organization completely outside the system, and it's going to get processed, and it takes about an hour. So what do I need to capture that?
Should just be a delay module.
It's a delay. It's only a delay. I'm not seizing any resource, nothing. So it's only a delay module. Okay. So here, obviously, in these functions, remember this is seize delay release. So I already released the technical person, the staff that was working on the call. And then here I also release the trunk line. So this entity is not seizing any other resource in this center. All I have to capture is that 1 hour that I'm going to send it to another. I'm going to ask someone else to help me with this question. So this is going to be the delay for offline research. And let's call it value added. And this is going to be exponential 60 minutes. And the units is minutes. Okay. So that's just some delay to capture that 1 hour work by some other people. And then the entity is going to come back. And at this point, okay. So at this point, when the entity comes back, when the call comes back, I want to find out what product type I'm looking at. So is it type product 1, product 2, product 3, and then go find the resources, the set associated with that product type, and then pick that specific resource that initially work with this person. So I'm going to actually put a decide module. I'm going to put a decide module. In this decide module, I want to define product type. Okay, so it's either going to be product type 1, product type 2, product type 3. Already, you know that when, okay, let me bring this. We know that here, when we had a technical call and we wanted to see if it's product type 1, type 2, type 3, we put this assign module here, right? Do you remember what we did in these assign modules that we added today? We did a couple of things for each call, which is tech support. What did we do? In this,
We assign the call type to be 1, 2, and 3.
we assign the call types. We also assign an entity type for each one of them. So now if they are product 1, I know they are entity type 1, they are entity type 2, entity type 3. So I assign a different picture and a different entity type and also a different tag for each one of these calls if they are for product 1, 2, 3. So now I'm going to use these things that I define here to decide if this call is related to product 1, product 2, or product 3. So I'm going to actually use n-way by condition. So this is obviously n-way because it's either product 1, 2, or 3. So obviously it's 3-way, it's n-way. It's not by chance because I'm not going to decide by chance if they are product 1 or 2 or 3. I already know what they are, so I have to use some condition to decide if they are product 1 or 2 or 3. So I'm going to use n-way by condition. And in this n-way by condition, the very first condition is that we can put a bunch of conditions here if the value attribute is this, if blah, blah. So one thing that we are going to do here, and again, for the sake of practice, we could approach this in a couple of ways. But for the sake of learning, I'm going to use entity type. And I'm going to say that if the entity type is tech call product 1, that's the one that I define here. When I define entity type here in this assign module, I called it tech call product 1. I called the entities that specific name. So I say if they are entity type tech call product 1, that's the first condition. So send them 1 way. Second condition, if their entity type is tech call product 2, then send them to a different way. And the third condition, if their entity type is tech call product 3, send them to a different condition, send them to a different route. Okay, I did that. So, however, if you have some, for example, other things other than entity type, for example, one other thing I have here is attribute, right? Remember, we defined the tech product type attribute or something when I gave value of 1 and 2 and 3 for the calls that go through the first and second and the third route. I could use that attribute value as well and say, look at the attribute of tech call type or whatever we define here. And then if it's value 1, go to the first route. If it's value 2, go to the second route. If it's value 3, go to the third route. So here, I'm going to pick entity type again, just as a practice, but we could do this in different ways. And I'm going to say, and if entity type is what I defined in the here, is in technical call product 1, go to the first route, technical call product 2 or technical call product 3, go to the first, second, and third route and press OK. And if you look here, in this decide module, all these conditions are here, and I have 3 arrows here for the first condition, the second condition, the third condition. So now, okay. If they are related to the first product, I'm going to first, okay, so if they're related to the first product or second product or third product, it does not matter. What do we need to do next? The call has the question that we had was sent out for 1 hour. That's what I have here. And now it's back to us. And I have looked at the question or the call or the whatever the question, and I know it's for product type 1. What I need to do next, logically.
You need to seize the trunk line again.
First, I need a trunk line. What else do I need?
The person that answered the call.
The person that answered the call initially. Okay, so what I'm going to do here is first, instead of just holding a line and just keeping it without having a person, first I'm going to see if that person that I want is available. So in the first seize module here, I'm going to first see if that I'm going to see if that person is available. Okay, so I'm going to put a seize here. So just make sure you have enough space, because we actually are going to need 3 C's for each one of these. Product 1, product 2, product 3. So I'm going to do 1, and then you can do the rest yourself. So let's do 1 together. So the first one, let's assume it's for product 1. So here, I'm going to say seize tech agent for product 1. Okay. Let's assume this is going to be a value added work. And what is the resource that I want? I'm going to pick it from a set. This set is the product type 1 set, because I know they are type 1 based on the condition I put in the decision module. These are the type 1 product calls. So it's related to product type 1 set. I'm going to only need 1 people in this resource. What should I put for the selection rule? How I'm going to pick the person from this set to answer the call?
Should be a specific member.
It's a specific member right now. Previously, I picked prefer order. I said, just pick the person based on the order that I put them in the set. But now I know exactly which person in the set answered this call, because I kept the index of that person in an attribute for each entity. So now I'm going to pick a specific member, and the index of this specific member is in tech agent index. That's the attribute that I defined when I assigned a person to a call. I saved the index of that person in this attribute. If you remember, we defined that attribute ourselves. We saved the index of the person that we assigned to that call in this attribute. Now that the entity is here, I'm going to pick a specific member. What is the index of that member? I'm going to look at this attribute of each entity, which saves the index of the person in the set that answered that call initially. Okay? So make sure to, for the resources set, you don't need to specify anything. Just make sure you pick a specific member and then pick the name of the attribute that actually saves the index of that specific member. Press OK. And okay, here. One more thing. When we pick this person to answer, these are the same set, right? The same set that was used. This is the same set of people that were used to answer a tech call initially at this stage. And now the call went out and now it's back. And I'm going again use the same set, the same group of resources to answer the call again. However, these calls that are returned have higher priority to be answered compared to these initial calls. Okay? So how I should give higher priority to these calls in seizing this resource that can also be seized in this process, in this function as well. How? By changing the priority here. So if I here change the priority to high, this resource that I'm going to seize here, which I also seized in this function as well, are going to have higher priority to be seized here with these entities. That way, the returned calls will have higher priority to seize this resource, and we can call those people back a lot faster than the original calls. Okay, so make sure you know you're clear on the priority part. This is important, guys, because you will use the priority thing a lot in future models and consulting jobs and everything you do. In previous session, we learned one way to deal with the priorities. We send all of them to the same queue, do you remember? And then we gave them attribute and we said, oh, you all are in the same queue. So look at the attributes to find out who is going to have higher priority to get that resource. Here it's a different way. Here these calls here and these calls here are going to use two different queues. They are not going to use the same queue. The calls here and the calls here are going to use two different queues. However, the resources that they are seizing is the same. They are waiting in two different queues to seize the same resource. The way that I tell the simulation that people in this queue have higher priority than the other queue is to assign higher priority here. Then the simulation will know that people in this queue will have higher priority in seizing the same resource. Okay. Press OK. And let's do the same for other seize operations as well. If it's for product 2, I want to seize tech agent for product 2. Let's assume this is a value added thing. It's going to be chosen from a set. The name of the set is product type 2 set. What is the selection rule? I want to select a specific member. What is the index of that member? Look at the tech agent index that these entities are carrying, the tag that they are carrying, and whatever value you see in that tag is the index of the resource that held that person initially. Press OK. Make sure to change the priority to high because this entity is waiting on the different line but is seizing the same resource. And I want to make sure the entities in this line will have higher priority in seizing that resource. And let me copy it once. And then for the third type, I'm going to pick a resource from the set. The name of the set is product type 3 set. I'm going to pick a specific member. The index of that member is in the tech agent index tag. So look at the tag that this entity is carrying. The value in the tag is the index of the agent who answered this call in the past. And I want to make sure this call is going to have high priority. And press OK. Okay. So let's connect the modules so far. Okay. Okay, so for now, we seized the person who should answer the call. And then now I want to answer the call. So for that, I'm going to go back to basic resources. I'm going to use processes, bring processes here. And in this process, I want to answer the call. However, in addition to the person that answered the call initially, which I seize here, I also need to seize a trunk line. So in this process, say return call type 1. And the function, the action that I'm going to pick is seize and delay. Okay, I will tell you in a second why I don't put release here. But let's pick seize and delay. Then what resource I want? I want one trunk line. And the processing time of these calls is this triangular, I think 249. Yeah, I believe triangular. Yeah, triangular 249. 249. And it's value added as well. Make sure you change the units to minute. So we picked a trunk line that this is a trunk line that we want. It's only 6 delay. The time is triangular 249. So let's do that for the other two as well. Okay. Make sure to connect those as well. So this is the person, the resource, this is the trunk line. We talk to the person, triangular 2 for 9 minutes. And now I want to go ahead and seize these resources that I have. Actually, we can do seize delay or seize delay release. It doesn't matter. If we do seize delay, then in the release that we do, we put both resources to be released. So I'm just going to put this back in the seize delay release. It absolutely does not matter, guys. So I'm just putting seize delay release. So we talk to the person, we seize the trunk line, we talk to the person, we hang up, and the line is released, okay? If I wouldn't do that, then when I put a release, so I'm going to put now a release module here because I still have one resource. What is the resource that I want to release here? What is the resource that I still have? I released the trunk line. What is the resource that I still have?
You still have the agent.
We still have the agent, so we want to release the agent. So we want to release agent one. Add So it's going to come from a set. This is product 1. This is going to be a specific member, which is in this tech agent attributes. So we want to release that resource, so I specified that. If here in this process, I just pick season delay and not the release for the trunk line, here in the release, I can also add another line and just pick the trunk line here and just release that here as well. So both of them are correct. So I can either you can put cease delay release or cease delay and release the trunk line in the release function, release module as well. Both of them.
Professor, real quick before you move on, did you use the tech agent index as the release rule? I'm sorry, I missed. Okay, you did.
No, don't worry. Yeah. For the release, I want to release a specific member. That's the person that I picked in the past, and I'm using this attribute to know which person. I'm going to pick it from a set. That's set 2. I'm going to pick a specific member. And how do I know which member? I look at the tech agent index attribute. And okay, so for each one of them, I release the resource, I pick the set, I pick product type 1 set, type 2 set, or type 3. I need to release the specific member, and this is the index of that specific member, which is in the tech agent index. It's okay. Guys, please make sure you save every single thing you do. Like this model right now is so big, we can't afford not to save it and suddenly it crashes and then everything is undone. So make sure to save, make sure to connect this. Okay. Now, I want us to be able to finish it. So make sure now that we are done, okay. Now we are done pretty much. There is one more thing that I think I won't probably find the time to say. So for now, I want to at least wrap up things and I will add it in the next section if you don't have them. So remember this is basically the end section that all the calls went to, right? So this is the end section that all the calls went to. And I want, after I finish all of these parts for the technical call, I want to send them to this little end because they have to go through this. So I'm just going to pick this little end and I'm just going to move it here just for the sake of I know what's going on, right? So here's what I did. So this is the little section at the end where all the calls go to. I removed the technical calls from this section because they needed to go through this additional part. Now that I'm done, I want them again to go through this part. So this part, the first module, if you click on it, is related to the releasing trunk line, right? However, for the technical calls, I already released the trunk line here in these functions, in these modules. So I don't need to repeat that again. I'm done. If you click on the second module here, it's for decreasing the working process which we needed in previous model because we use working process for the terminating condition. But right now we learned, in this model we learned that I'm not going to use working process, I'm going to use NR trunk lines as the number of trunk lines that are busy to represent my working process. So I don't need this assignment anymore, so I can delete it. And then this record module is going to, this release trunk line is going to just go to the record module. And here is when we recorded the number of calls completed and so forth. So now I'm going to return, just when the call type 1 is done, I'm going to add it to the record completed call because I don't want to release the trunk line. So I already have released the trunk line, so I don't need the first one. I deleted the second assignment module. I didn't need that anymore. So here. Okay. So we did that. And then we should be good. So now let's just run it and see if we get any error. Unconnected exit point. Where is that?
I think you didn't connect the file defaults for design module. The one with the outside research.
Yeah, this one is the one that doesn't need the outside research and just directly goes to release trunk line. Yeah, so guys, pay attention. Remember here I had a decision module outside research. For the 4% that needed outside research, this is where we ended up. But for that 96% that do not need outside research, we have to come to the release trunk line here at the bottom. We have to come to the release trunk line first because we did not release their trunk line or anything. They still have their trunk line. We have processed them. We have processed them. They don't need any additional research outside. So I just connect them to the release trunk line and they are good to go. So in these modules, I already released the resource that was working on them. And then in this module, I released the trunk line that they had occupied as well. And they are going through the rest of the process, so we are good. Oh, I see. So I should have put 2. Then let's click, sorry guys, let's click on the decide. So let's define the product type. Do you see that one? Define product type decision module. So let's click on that. So I defined 2 conditions, right? 3 conditions here. I said then entity type is product 1, entity type is product 2, entity type is product 3. I shouldn't. I should just define the first 2 conditions and the third conditions will automatically be this one, right? So just delete the last condition. Okay, so when entity type is product 1, we use first condition. Entity type is product 2 is the second condition. I automatically put entity type product 3, but that's the else condition, right? So we don't need to put that. Everything that meets that condition will automatically go to else. So in that scenario, then the first condition is related to the first one, which is related to product 1. The second condition is related to the entities that are product type 2. The else is going to be connected to the third section that is related to product type 3. And we should be good. For the max arrival, type infinite. I put INF type infinite, and that's it. For the arrival, create call arrivals. For the max arrival, put infinite. So the second part that we want to add, the part that we need to correct is related to the calls that when we pass the 600 time, because remember, we said the simulation, the working, the arrival of customers is in 600, in 600 minutes or 10 hours. However, the simulation is going to run for longer time. So still the simulation wants to calculate this index that we have identified here. So still the simulation wants to calculate this when the simulation passes 600. However, it gets an error in defining this set. So we have to just see what we need to do here so that we can pass that error. So keep that one and in mind. And then there is one more, actually two more modules that I want to add here. And in these modules, I want to count number of rejected calls of each product calls. Number of calls that went outside for each product type. So I want to calculate that as well. So we are going to learn how we are going to use add variables that have multiple elements. So keep that, which I want to, we keep that one for the next session, which I want to add here. So we are going to add two modules here to see how we can count number of calls of each type that went outside and came back to the system. Also, we will see how we are going to modify this record module so that we can record the calls throughout the whole simulation time, even if we pass the 10 hours of simulation. So keep that, what time is it? It's 12:53. So save your model, guys, and keep that, and I will get back to it in the next session so that we can just run it and see the results and interpret the results, okay? Is there any question? Okay. I need one more session to finish chapter 5. And after that, we can have our exam, which will be chapter basically 3, 4, 5, because 1 and 2 are just basic simulation definitions and things like that. So we started to learn the modelings more in chapter 3, 4, 5. I need one more session to finish chapter 5. So if we take next week to finish chapter 5, can we plan for the week after? So let's see. Next week, 26, is going to be, we are going to finish chapter 5 then. November 2nd, is that good, guys? Work for everyone? That's the day before election. November 2nd. We'll have our midterm then, which includes everything we have learned by then, including chapter 5, which we will finish next session.
And Professor, like, what can we expect in terms of the format of the exam?
If you guys feel comfortable with the models we do in class, if you guys feel comfortable with the assignments I give to you for the homework, and the assignments I give to you sometimes, if you have some time in class, I give you additional assignment. If you guys feel comfortable with those, you are good. For the exam, there's no like definition type of question, nothing. Exam is similar to homework. I give you, so it's during the class and you have 3 hours. I give you either 1 or 2 modeling questions, similar to the assignment, similar to the homework. I give you the problem statement, 1 or 2, and then you just read it. You create the model, you create a Word file in which you are answering the questions that I have asked you guys, exactly similar to the homework. I gave you a naming instruction that you have to follow, and then at the end, put everything in a zip file, in a zip folder, zip it, and upload it on Blackboard. So make sure you guys are comfortable with zipping the folders and so forth, so I don't have issue later opening up the zip files and where should be uploaded and blah, blah. So make sure all of you know where to upload the assignments. So I created an assignment on the assignment folder, similar to the homework. For the exam, I give you the question, 1 or 2 questions. I haven't decided yet. However, just note that these questions, since we already have learned a lot of techniques, these questions would just have a bunch of techniques. So a combination of techniques in each question. And do the model, run it, make sure the model runs, run it, answer my questions in the Word file, put everything in the folder, make sure the naming convention is correct, zip the folder, upload it, and you're good to go. And I will be here during the exam as well. If you have any questions or anything, I'm here as well to answer your question. Guys, so save this model, keep it. Next session, we are going to add those additional modules and see what do we need to add to the record module. And I will assign the homework. I will see, like, I will look at the homework, and hopefully with everything you have learned, you are able to finish it. If not, I will assign it so you will start working on it. And then after next session, you can finish it. So I'll do that. I'll post the video after I find the chance to edit it. And that's it. Any question, guys, other than homework? If there's no question, you can log off. Goodbye. I'll see you guys next week. Watch for my emails regarding the homework.